The Symons cone is world-renowned as a crusher of metallic and non-metallic ores, and in the production of aggregates from stone, gravel, and slag. It has always been difficult to explain the unique crushing action of the Symons cone. So some years ago, we actually cut a hole in the side of a 4-foot Symons standard cone crusher and shot movie footage of the crushing action to permit a comparison between the Symons and a conventional small-throw gyratory crusher. This is an early model of the Symons. Many improvements have been made over the years, but the crushing principle and action are identical in today's models. This normal speed scene shows the profile of the crushing cavity and movement of the head. In slow motion, it's easy to see the crushing action. The high speed and wide travel of the head provides a large, unrestricted opening momentarily, but closes soon enough to limit the discharge to rock crushed in the lower and narrowest portion of the crushing cavity, called the parallel zone. No unreduced material can pass through the crusher. This is a small-throw conventional gyratory crusher. Note how the material slides down the head, and the congestion in the lower crushing zone near the restricted discharge opening. Compared to the conventional gyratory, notice how open the Symons crushing chamber is, allowing the material to be successively reduced in size until small enough to drop through. You can get a good idea of the amount of kinetic energy being effectively applied to the material being crushed by how the material literally explodes into successively smaller pieces. The Symons cone uses horsepower very efficiently. A series of retouched pictures will show the crushing action of the Symons cone as the rock receives the initial impact. The material being reduced falls freely when the head moves away from the side of the bowl, being crushed still smaller when the crushing cavity closes again. The cavity is open again. The head is at its closest position, further reducing the material. The bottom of the bowl and the bottom of the head increase in circumference so that there is a greater crushing area the further down the material flows. The material being crushed continues to fall until it reaches the parallel zone where the crushing surfaces are parallel. Product from the Symons cone will always have at least one dimension equal to or less than the size of the opening at the discharge point. It just can't fall through until reduced to this size. The particles can fall vertically with minimal friction between the material and the crushing surfaces. You'll note that in this gyratory crusher, material seems to jam up and work against itself. There is not the free flow of material as in the Symons. With the Symons design, a succession of crushing impacts reduce the material, and each time the head swings away from the bowl, there is plenty of room for fines and smaller pieces to drop right through. At this point of stop motion, it's easy to see how the head and bowl surfaces are almost parallel. They are fully parallel at the point of each stroke, where there is the smallest opening. Watching this crushing action, it's easy to see why so many users prefer the Symons cone crusher for high production and product uniformity. This is a cutaway of the top portion of a Symons cone crusher. The area outlined by the white square is shown here in close-up to show how the crusher is protected from damage by any non-crushable object. When the head contacts the non-crushable, the bowl itself raises up against heavy springs which absorb the shock instead of cracking the bowl. Here the action is repeated, this time for the right side of the crusher. The Symons cone crusher is equipped with a pressure lubrication system designed to supply large amounts of oil for both lubrication and cooling to all bearing surfaces, as well as the gear and pinion assembly. Low bearing pressures, large bearing areas, along with adequate lubrication, all contribute to long life of the wearing parts. These are the paths the lube oil takes through the crusher.